Hello everyone, my name is Savannah Ziandini. Here I want to share with you some reference and study note that I get from the paper. So the title of the paper is the programmable and customized intelligence for traffic steering in 5G network using Open RAN architecture. So I take some note here from this paper. One of them is the problem addresses in this paper is the lack of fine-grained control and optimization of the network functionalities customized to individual user in the current cellular architecture. The document focus on the development and evaluation of an intelligent traffic steering solution in the context of open RAN architecture. Specifically, the paper formulates the optimization problem for traffic steering and discuss the algorithm design to determine the optimal target cell for handover and user equipment. Its purpose, the a data-driven UE based traffic steering handover optimization technique based on conservative Q-learning, which is the first of its kind. The document highlights the challenge associated with designing and testing intelligent run control solution, including the need for large-scale data collection and isolated environment for training and testing. The challenge and importance of the problem is the challenge and traces in the document is the lack of fine-grained control and optimization of network functionalities customized to individual user in the current cellular architecture. This limitation hinders the efficient management of handover and mobility for different use cases. The importance of the addressing this challenge lies in the need for advanced network uh, control and optimization in 5G network to meet diverse requirements such as high quality video streaming and ultra reliability, low latency communication for autonomous vehicle. The document emphasize the importance of developing intelligence runs control solution to embed into the XApp, enabling to optimization of handover decision tailored to the quality of service requirement of each user. The problem is crucial for realizing the full potential of ORAN architecture, which aim to provide programmable and customized intelligence for traffic steering. So for the assumption, yes, it assumes the use of open run variant and its specification for closed loop control and intelligent optimization of the radio access network run at the user level. The document also assumes the use of the software from calls ns3-oran that integrated a real-world near real-time run intelligent control or near arterial with a simulated environment on NS3 for the development, testing, and evaluation of custom run control application or XApp and deep reinforcement learning DRL driven control policies. For the performance metrics, consider for the evaluation of the proposed traffic steering solution in the document include throughput, channel quality, spectral efficiency, and mobility overhead. For throughput, the average user throughput at the packet data convergence protocol (PDCP) layer is reported, which include both LTE and R split barrier. The document also discuss the 10 and 95 percentiles of user throughput, showing improvement for both the worst and best user compared to baseline heuristic. Channel quality is represented by the signal to interface plus noise ratio (SINR) and its cumulative distribution function (CDF) is analyzed to show the performance gain of the proposed solution. The spectral efficiency is evaluated by analyzing the average spectral efficiency per user and per cell, as well as percentage of physical research block uh, PRBs used for downlink traffic. The mobility overhead is evaluated as the number of handover per unit time weighted by a throughput factor, and document shows that the purpose solution avoid adding more handover compared to baseline strategies while delivering better throughput. Overall, this performance metric provide a comprehensive evaluation of the proposed traffic steering solution effectiveness in improving network performance in terms of throughput, channel quality, spectral efficiency, and mobility overhead. Basic concept of this document is the document provides an overview of programmable and customized intelligence for traffic steering in the 5G network using 5G RAN architecture. It discusses the limitation of the current cellular architecture in terms of fine-grained control and optimization of network functionalities for individual user. To address this gap, the document proposed the use of the Open RAN paradigm and its specification, which introduced an open architecture, which abstraction and enable closed-loop control and intelligent optimization of radio access network at the user level. One of the key components in this purpose architecture is software framework called ns3-oran, which integrated a real-world near real-time run intelligent control or near RT with a simulated environment on NS3. This framework allows for the development of custom run control application, XApp, and facilitate large-scale data collection and testing of deep reinforcement learning DRL-driven control policies. Document also propose user-specific or traffic steering intelligent handover, a framework which optimally assign a serving-based station to each user in the network using a combination of algorithm. The performance evaluation of this framework shows improvement in throughput and spectral efficiency compared to traditional handover heuristic. Overall, the document highlights the challenge associated with designing and testing intelligent run control solution and embracing the need for large-scale data collection and isolated environment for training and testing. It provides insight into the development and evaluation of an intelligent traffic steering solution within the content of open run architecture. The result is in the document, the result of the performance evaluation of a purpose framework from traffic steering in 5G network using open run architecture are discussed. The evaluation compared the performance of the run and intelligence control RIC using reinforcement learning RL agent for baseline handover control policies. The result shows improvement in large user throughput, spectral efficiency, and other key performance metrics. The RL agent demonstrated adaptability across different frequency bands and showed the significant gains for different types of traffic, such as video streaming, web browsing, and instant message. That the result also highlighted to customization of handover management for individual user and scalability of approach. Furthermore, the RL agent improved the spectral efficiency and throughput while keeping its mobility overhead similar to and lower than the baseline. Thus, the result demonstrates the effectiveness of the purpose intelligent traffic steering solution in optimizing network performance in open run architecture. So for the next step is for simulation. For this simulation, I need to install some Docker 19.03. So I need to run some command in the terminal so I can get the like here I need to install NVIDIA Container Toolkit, install NVIDIA Container another toolkit and package library and add dependencies of package, and I need to start the Docker. So next execute the Docker. So and there's another I need to install here like CMake and G++ and Python to improve the ns oran setup. So for the next one is for near RT rig setup. I need to clone from the Colosseum near RT rig. So I get it, and I try to run some or import all the image we need in Docker, and then properly, and we build and launch them. So when I try to import the image that I need in Docker, I get this. So it's take a long time to get this, and for another one is same take a long time. So yeah, maybe you can take some coffee and etc to wait for this, and then and the next is I have some note here because we need two terminal. One of them is for logs the E2 terms. So we need to keep it open. And for the next one is we need to build and run the XApp container. So when I try to build it, I get this. Sorry, maybe I when I start the XApp ns3-oran XH, yeah, it's take a long time too. So for the next one is we need to move to home and sample xapp directory inside the Docker container and run the xapp logic such as like this. So I run it and I got this. So for the next one is for the ns3-oran setup, we need to clone it from the GitHub. Yeah, and the name is oran itu sim slice itu sim, and then we need to clone another dependencies or some yeah, we need to install it like ns3 millimeter wave from ns3 millimeter wave projects. So I got this. I need to git clone it and make some contribution inside this. So after that, we need to build the ns3. First, we need to configure the ns3, and next we need to build the ns3. So it's take a long time, and sometimes I got some delay for this one. So sometimes we need to like restart it and try to type the comment again until we got this, until it finished, and like the build finished successfully. So we got this comment and the next one. So it's mean we finish to build the ns3. So for the next one is we need to run some scenario. Here we have I think more than one scenario, but I try this scenario, the scenario 0.cc, and this is there is in the scratch folder. So yeah, just run it. So I got this. Yeah, that's all my study note. Thank you. See you next time.